Hello everyone. Today I am going to continue with Module 3 Partial Differential Equation of your subject 18MAT21 Advanced Calculus and Numerical Methods. So before we start with this session, it's better you all revise what you studied in the previous sessions, like formation of PDE by eliminating arbitrary constants as well as elimination of arbitrary functions. Also, you have found the solution of non-homogeneous PDE and also the solution of homogeneous PDE. Now, in this video session, I will be discussing about Lagrange's first order and first degree PDE of the form PP plus QQ is equal to R. The PDE will be of the form PP plus QQ is equal to R is called Lagrange's first order PDE. Now what is PP and what is capital P, what is capital Q and what is capital R? They are all functions of X, Y, Z. P, Q, R are functions of X, Y, Z. Now the general solution of this Lagrange's PDE of the form PP plus QQ is equal to R is given by f of u comma v is equal to 0. So how to find the solution? I will explain this. The solution of this Lagrange's PDE will be of the form f of u comma v equal to 0. Now, since the elimination of arbitrary function f from this leads to the Lagrange's differential equation, linear partial differential equation. Now, how to find the solution of this Lagrange's linear PDE PP plus QQ is equal to R? We'll just go through the method, then I'll explain you with an example. First, you write down the given equation in the standard form PP plus QQ is equal to R if it is not in the standard form. If it is given in this form, it is okay. If it is not given in this form, rewrite in this form. PP plus QQ is equal to R. What is this P? Dy by dx, and this is dou z by dou x, and this is dou z by dou y. Now, if the equation in this form, this standard form, the first step here is to write down the auxiliary equation. That is dx by p is equal to dy by q is equal to dz by r. This p, whatever you have, function of x, y, z, comes here, q comes here and r comes here. Dx by p is equal to dy by q is equal to dz by r. So this is known as auxiliary equation. Now u is equal u, that is a function of x, y, z, is equal to c1 and v of x, y, z is equal to c2 are said to be the complete solution of these equations, provided u1 and u2 are linearly independent. That is, u1 by u2 is not a constant. Now, how do you find this u and v? The first case is one of the variables is either absent or cancels out from the set of auxiliary equations. When you written the auxiliary equation, see the set of auxiliary equations. If one of the variable is not there, or when you compare the two equations, if one of the variables get cancels, then one of the variable will cancel. If not, if u is equal to c1 is known but v is equal to c2 is not possible by case 1. If you get u is equal to c1 but v equal to c2 is not possible, then you consider u is equal to c1 to get v is equal to c2. Okay, this elaborately I will explain when I work out the problem. Next one, introducing multipliers. You multipliers you introduce P1, Q1, R1 as functions of x, y, z or constant, so that each fraction will be equal to P1 dx plus Q1 dy plus R1 dz divided by P1p plus Q1q plus R1 r. Here you have multiply the first one by P1 dx plus Q1 dy plus R1 dz divided by P1p plus Q1q plus R1 r. So it becomes the ratio of this fraction. Now you can also choose multipliers such that the numerator becomes the differentiation of the denominator. So when you integrate, you will get combining 4 with a fraction of 3 to get an integrate. You can choose the multiplier such that the numerator becomes the integral of the numerator becomes the differential of the denominator. All these cases, when I work out the problems, I will explain you. When we go to the problems, we refer this and work out. So finally, you write down the general solution as f of u comma v is equal to 0 or v as a function of u. F of u comma v equal to 0 or v is equal to phi of v. So take up one problem. Solve mz minus ny dou z by dou x plus nx minus lz dou z by dou y is equal to ly minus mx. So now you can observe here the equation of the form pp plus qq is equal to r. This is your p, this is your q, small pq, and this is a function of xyz. So capital P, this is capital Q, and this is capital R. What are the auxiliary equation? dx by p mz minus ny, dx by mz minus ny is equal to dy by nx minus lz, that is q, is equal to dz by r, r is ly minus mx. Now you can observe here you have mz, here you have mx, ny and nx. So if you multiply this by x, this will be mxz, and if you multiply this by z, this will be mxz. So common similar terms will come. So it's better you use the multiplier x here, and here it is z. Similarly, if you use x here, nxy, so you need to use y here, nxy. So what are the multipliers we use? Using the multipliers L, M, N, or I have done here x, y, z. Using the multipliers x, y, z, each ratio in 1 is equal to, observe here, x dx plus y dy plus z dz. Your numerator will be x dx plus y dy plus z dz divided by mxz minus nxy plus, this you are multiplying by y, nxy minus lxz, this you are multiplying by z, lyz minus mxz, right? X dx plus y dy plus z dz divided by this. So simplify the denominator, you will get it as 0. X dx plus y dy plus z dz is equal to 0, which on integration gives, integrate this, x square by 2, y dy integration is y square by 2 plus z square by 2 is equal to a constant, or x square plus y square plus z square is equal to a constant, 2c2, or you can take it as a constant. So that is one we have found, either u or v, both you need to find. You have found one of the solution. How do you get the other solution? As I told you, you can observe here, you have mz and here you have lz. So if you multiply this by L and this by M, LMZ, and this will be LMZ. So multiply this by L, this by M, and this by N. Use the multipliers L, M, N. So that each ratio will be equal to L dx plus M dy plus N dz divided by L into mz minus ny plus m into nx minus lz plus n into ly minus mx. See, verify, what do you get? Denominator lmz get cancels with minus lmz, lny minus plus lny, mnx minus mnx. So all the terms get cancelled. So 0. Numerator will be L dx plus M dy plus N dz divided by 0. So the numerator must be equal to 0. L dx plus M dy plus N dz is equal to 0, which on integration gives integrate L dx Lx plus integration of M dy My plus integration of N dz, that is Nz, is equal to C1. So you have got one solution as Lx plus My plus Nz is equal to C1, and one more as x square plus y square plus z square is equal to C2. So this is U is equal to C1 and this is V is equal to C2. So your general solution will be phi of U comma V equal to 0. First you can find this, then you can find that the order is immaterial. U and V, first you can find U then V, or any way you can write. This can be written as phi of Lx plus My plus Nz comma x square plus y square plus z square equal to 0. Or you can also write it as, first you can write x square plus y square plus z square, then Lx plus My plus Nz. We'll go to the next problem. Solve x square into y minus z dou z by dou x plus y square into z minus x into dou z by dou y is equal to z square into x minus y. So this is the equation of the form PP plus QQ is equal to R. What is capital P? X square into y minus z. What is capital Q? Y square into z minus x. And what is your R? Z square into x minus y. So write down the auxiliary equations. Dx by P x square into y minus z is equal to dy by Q y square into z minus x is equal to dz by R z square into x minus y. Now you have here x square y. So look for the similar term. You have here y square x. Right? So if you use the multipliers, or if you use the multipliers here, so I mean to say, if you use the multipliers 1 by x square, 1 by y square, 1 by z square, x square, y square, z square get cancelled, y minus z plus z minus x minus y will remain, right? That will be equal to 0. So first use the multipliers 1 by x square, 1 by y square and 1 by z square. So what you get is 1 by x square dx plus 1 by y square dy plus 1 by z square dz, numerator. Denominator you will get 1 by x square into y minus z. So x square get cancelled, plus 1 by y square into y square into z minus x, y square get cancels, plus 1 by z square into z square into x minus y. So you are left with y minus z plus z minus x plus x minus y in the denominator, and that will give you 0. So what do you get from this? 1 by x square dx plus 1 by y square dy plus 1 by z square dz is equal to 0. Integrate. What is the integration of 1 by x square with respect to x? Minus 1 by x. Integration of 1 by y square dy with respect to y? Minus 1 by y. And integration of 1 by z square with respect to z is minus 1 by z equal to c1. So you can multiply throughout by minus 1 by x plus 1 by y plus 1 by z is equal to c1. So this is one of the solution, u is equal to c1. How do you get the other solution? What may be the other multipliers you can use? So as I told you, you have x square y and here y square x. So if you multiply this by y, this will be x square y square, and you multiply this by if you multiply this by this by 1 by x, multiply this by 1 by x, this will be xy, and this by 1 by y, this will be minus y, and 1 by z. Use the multipliers 1 by x, 1 by y, and 1 by z. So see what do you get? Each ratio is equal to 1 by x dx plus 1 by y dy plus 1 by z dz is equal to x into y minus z plus y into z minus x plus z into x minus y. So denominator will be ultimately 0. So numerator you have 1 by x dx plus 1 by y dy plus 1 by z dz. That must be equal to 0. Integrate. What is the integration of 1 by x? Log x plus integration of 1 by y dy log y, and this is log z is equal to, take it as log c2. What is log of x plus log y plus log z? That is log of x, y, z, and that will be equal to log c2. Log of x, y, z is equal to log c2, or x, y, z is c2. So hence the general solution is phi of u comma v equal to 0. What is your u? 1 by x plus 1 by y plus 1 by z, and what is v? x, y, z. So your solution is phi of 1 by x plus 1 by y plus 1 by z, comma x, y, z is equal to 0. Okay, here you have a very simple problem. Solve xp minus yq is equal to y square minus x square. Again of the form pp plus qq is equal to r. What is capital P? Is a simple function x, capital Y, capital Q is y, and z is y square minus x square. So write down the subsidiary equations. Dx by p is equal to dy by q is equal to dz by r. P is x, q is y, and r is y square minus x square. Now you can observe, always you need not use the multipliers. The first two terms here, first two equations are very simple. If you consider the first two equations, dx by x is equal to dy by y, see here, dx by x is equal to dy by y, and integrate. What is the integration of dx by x? Log x, and this is log y. Log x is equal to log y plus log c1, or log x minus log y is equal to log c1. What is log x minus log y? Log of x by y. So log of x by y is equal to log c1, or x by y is equal to c1. Now to get another relation, we choose the multipliers. You can observe here you have x, here you have x square. You have x here, and here you have x square. So if you multiply this by x, and similarly you have y square and here y. So you can multiply this by y. So use the multipliers x, y and 1. See what do you get? Use the multipliers x, y and 1. What is your numerator? X dx plus y dy plus dz divided by x square plus y square and plus 2. Once again, if you use the multipliers x, y, 1, you will get x dx plus y dz, y dy plus dz is equal to 0. So numerator will be x dx plus y dy plus dz is equal to 0. Integrate this, x square plus y square plus by x square by 2 plus y square by 2 plus z is equal to c2, or x square multiplied throughout by 2, x square plus y square plus 2z is equal to a constant. So what is your u? U is x by y, and v is x square plus y square plus 2z. So phi of u comma v is equal to 0 is your final solution. Okay, consider one more problem here. Solve x square minus y square minus z square p plus 2xy q is equal to 2xz. So pp plus qq is equal to r. So what is your capital P? X square minus y square minus z square. What is your q? 2xy. And what is your r? 2xz. So pp plus qq is equal to r. Write down the subsidiary equations. Dx by p, that is x square minus y square minus z square, is equal to dy by q, q is 2xy, is equal to dz by r. R is again 2xz. So dx by p is equal to dy by q is equal to dz by r. These three your subsidiary equation. Don't consider this for the time being. Now consider only the first three subsidiary equations. You can observe here these two looks very simple. Dy by 2xy is equal to dz by 2xz. So if you consider these two, second and third relation, I think you can cancel 2x. 2x could be cancelled. Dy by y is equal to dz by z. If you cancel 2x, dy by y is equal to dz by z. Dy by y is equal to dz by z. So upon integration, if you consider dy by y is equal to dz by z, upon integration, what is 1 by y dy? Integration is log y is equal to integration of 1 by z dz is log z plus a constant, say that it be log c1. So log y is equal to log z plus log c1. So log y minus log z is equal to log c1. or log of y by z is equal to log c1. Log you can cancel, you will get y by z is equal to c1. So this is one of the solution, u is equal to c1. So how do you get the other solution? For the other solution you can observe here, I have used the multipliers x, y, z. When you use the multipliers x, y, z, here the terms are entirely different. So none of the terms get cancelled. So x dx plus y dy plus z dz divided by x into x square minus y square minus z square plus y into 2xy plus z into 2xz. Here it is 2xy. So x, y, z multipliers, and I consider third and fourth equation. Third and fourth equation. See what do you get? Dz by 2xz is equal to x dx plus y dy plus z dz divided by x into x square plus y square plus z square. So x is common here in the both side. So x you can cancel. I think 2 is also common. So x is common. You can observe here. Go back and see. Here x if you take out, x square minus y square minus z square, and here you have 2xy. X if you take out, 2y square, and here if you take x out, 2z square. So you are left with x square plus y square plus z square in the denominator. X you are cancelling. X you cancel. Dz by 2z is equal to x dx plus y dy plus z dz divided by x square plus y square plus z square. X you cancel. And this 2 you can multiply here, cross multiply. 2 into x dx, 2y dy plus 2z dz. What is 2x dx plus 2y dy plus 2z dz? That is nothing but differential of x square plus y square plus z square. So dz by z is equal to d of x square plus y square plus z square divided by x square plus y square plus z square. So numerator is the differential of the denominator. So now you can integrate. What does the integration gives? Log z is equal to log of x square plus y square plus z square plus log c2. I have written log c2 on the other side, doesn't matter. You can write any way you want. Log z is equal to log of x square plus y square plus z square plus log c2, or z by x square plus y square plus z square is equal to c2. So what is your required solution? Your required solution is phi of u comma v equal to 0, and your u is y by z is equal to c. Refer back and see. Y by z is equal to c1. This is your u is equal to c1, and this is your v is equal to c2. So phi of u comma v is equal to 0 is your final solution.